Hi, everybody, and thank you for joining us today for our webinar, Title 24 Building Envelope Changes. My name is Kim Melton, and I'm going to be the moderator for today's presentation. Before we dive into introductions, I do want to go over a few logistics. First and foremost, if you have any questions or concerns throughout the webinar, you can submit them at any point during the presentation via the Q&A feature. And if the Q&A feature is not available on your screen to the right side, you can actually click those round circles at the bottom of your screen, click the one with the ellipsis in it, and you'll see a Q&A open up in the top part of that menu, and then you just open that and it'll open to the right side of your screen. And so that'll allow you to submit questions at any point in time, and we will address them all at the conclusion of the webinar. A quick note, today's webinar is for educational purposes only and should not be used as a substitute for professional engineering design consultation or documentation that may be required for by building codes, contracts, or even applicable laws. So if you have any questions after the webinar, you can refer to our specific application guidelines or instructions that are located in the product sections of our website. Additionally, we're going to follow today's webinar with a survey, and this is your opportunity to provide us with feedback on how we did today. You can ask any questions you may have about the topic of the webinar, or even suggest future topics for new webinars if there's something that you'd like to hear. Now, this survey is part of how we deliver the JM experience to you. And the JM experience is based on 4 pillars of the JM culture, and you can see those listed there in the bottom left corner of the screen, and that's people, passion, perform, and protect. Now, we believe it's critical to make sure that when we hear and understand and respond to your needs in order to deliver the best interaction to you. And we offer webinars like this one to help educate the market and offer a tool and a resource for you and your business. But this isn't just a one-way street, so your feedback is a key component to that, and it's crucial to helping us better evolve to meet your needs. So if you have any comments or suggestions as to how we can better accomplish this, or maybe even feel like we've missed the mark today, we encourage you to fill out the survey, and we'll use your feedback to improve our webinars and provide the information that has the most value to you in future webinars. But with that, I'm going to hand it over to J.R. Babineau to introduce himself.
Thanks, Kim. So good afternoon or good morning, everybody. My name is J.R. Babineau. I am a research manager in corporate R&D at Johns Manville. I'm also our principal building scientist, and that's kind of the hat that I get to wear today in talking to you about Title 24. So just really quickly, we're going to start the webinar off today talking just a little bit high level about what is California's Title 24, you know, what's its relevance, a little bit of the history there. We're going to then kind of dive into some of the changes that have occurred in the 2019 version of Title 24, and that's these next few bullet points: the energy design ratings, changes to walls and attics, some examples and solutions. And just to kind of set the boundaries a little bit for everybody, Title 24 actually covers all buildings in California. We're going to focus on the changes to the residential part of that code, so single and multi-family residential. And kind of beyond that, we're also going to focus a little more down on the building envelope and impacts to things like insulation and air sealing, which of course is where Johns Manville delivers our solutions. So first off, right, what is Title 24? And really, this is part of an effort from California to go, as we say, very green. California has got a lot of policies and programs in place. Title 24 is one, that's effectively the building code. But then also there are goals in California towards having net zero buildings. We'll talk about that in some more detail in a minute. California has also got a pretty deliberate and aggressive plan in place to address their impact on climate change and greenhouse gas emissions, and just even more broadly, the state has got goals around wanting to simply be more energy efficient and how that can impact their economy and jobs. So first, Title 24 itself. Title 24 is effectively California's building code, and it came about in the 1970s. Title 24 Part 6 is really what we'll be talking about today, and that's the energy part of the building code, and it impacts both residential and non-residential buildings. The state is very regular about updating this code every 3 years. And again, the latest release that just went into effect is the 2019 version. That went into effect on January 1st of 2020. And another part that's related to this is the Clean Energy Jobs Plan, which Governor Brown rolled out a number of years ago, and again, it references Title 24 as an engine to help drive job creation as part of a clean economy. So related to net zero energy, or zero net energy, buildings, and really what that is a home or a commercial building that on average produces about as much energy as it consumes. And the goals here around zero net energy buildings is that by the end of 2020, which we're here now, new homes should be zero net energy within California. The goal for commercial buildings is to have new commercial buildings be zero net energy by 2030. So on both of these fronts, these are pretty aggressive and ambitious goals, and I think the state feels like they're pretty much getting there for homes, and the next step will be commercial buildings, which will be another probably big lift over the next 10 years. Related to climate change, California has what's called their climate change scoping plan, which is a long-term strategy that was put in place with the goal to reduce California's greenhouse gas emissions by 40% by 2030 compared to 1990 levels, and by 80% to 2050. And really the plan here is to build on efforts, right, that are already underway. A big part of this is Title 24, because buildings in general use around 40% of the total electricity consumed on the grid, and of course that contributes a lot to greenhouse gas emissions, especially in a state like California where there's a lot of air conditioning that gets used. Also, California has got a long-term energy efficiency strategic plan, and that's really meant to address energy efficiency in all segments of the California economy. Right, so buildings, residential, commercial, industrial buildings are there at the top of the slide, but also agricultural, HVAC equipment, codes and standards, really you name it, there are long-term goals in place to improve California's energy efficiency, again, beyond 2020, which is where we're at now. So now we're going to kind of dive in a little bit more to Title 24 itself, and specifically, again, the residential part of the standard. And so this slide, we really just got some highlights, but some of them are pretty important because there's been quite a few changes to the residential part of Title 24 just put in place this year. One is what's called the new Energy Design Rating, or EDR. In previous versions of Title 24 for homes, builders could choose to install renewable energy like photovoltaic, PV, solar onto their homes and get credit that would trade against things like insulation in walls and attics. That trade-off in this version of the code has been removed. So that's really a big change that we'll dig into here in a minute related to this EDR rating system. Another big change is that multifamily rules have been kind of broken out separate from single family, and that's honestly part of a trend in separating multifamily out that we'll talk about more later. There have been some mechanical and hot water and lighting changes. I'm not going to go into those because frankly we could talk all day if we were to cover everything that changed in the code. And then of course building envelope changes, and that's really what we're going to focus on in today's webinar. So first, the Energy Design Rating. What this essentially is a single number rating, kind of like a miles per gallon. If anybody on the call is familiar with HERS rating or the ResNet program, right, it's basically a comparison between the house that you want to build and some reference house. And we take a ratio of the amount of energy that each of these homes uses, and then we get a rating for it. So on the good side, a zero EDR or a zero rating number would basically be a zero net energy building. On the other end of the scale, I mean, that's usually, we think of these rating systems as going from 0 to 100. In reality, they can go negative and they can be greater than 100 for a really poorly performing building. But in California, the EDR, or the Energy Design Rating, has basically three components. There's an efficiency component, which includes things like insulation, air sealing, the efficiency of your heating and cooling equipment, and is related to how all of those things consume energy. There is then the EDR that's called EDR PV, which is really, though, anything to do with renewable energy. So it could be solar panels, it could be battery storage, it could be other sorts of kind of demand flexibility measures. And then there's this total EDR, which is basically the efficiency number minus the renewables number. And when it comes to complying with the new version of the code, there's actually two measures. There's a target, an EDR target just for efficiency that has to be met, and that's kind of this first bullet, right? So the EDR, the efficiency EDR of the new building has got to be less than or equal to the efficiency EDR of some reference, usually prescriptive path style building, and the total EDR, again, must be less than or equal to this total standard score. And what that's basically doing on the renewable side is it's assuming that you're going to install solar or batteries and solar or some combination of that enough to offset the total annual electric use or electric demand of the home. So we're going to move on and talk about walls and attics. And first off, we're going to talk about attics. I find that the easiest way to kind of start these conversations is related to the prescriptive options that are laid out in some pretty big tables in the building code in Title 24. Even though a lot of builders end up using different approaches, they end up using performance approaches. But from a prescriptive options, these have actually been simplified a little bit. They're basically the first decision in terms of how to comply with the code would be to ask yourself, where is my heating and cooling system, my HVAC, and where's my ductwork if I have any? Is it in the attic or is it in conditioned space? If it's in the attic, and if my attic is a traditional vented style attic, then the requirements for insulation, the prescriptive requirements for insulation would be that we are still going to put usually R30 to R38 worth of loose fill insulation down on the attic floor, and then we're going to put R19, usually bats of some sort, directly up under the roof deck. Now, down at the eaves, we're going to have to use vent chutes and baffles to still keep that vent space open, but this is kind of the insulation approach that is prescriptively described. And even if as a builder you're going to use the performance path, it's important to realize this is what you're being compared against, right? So any changes we make is pegged back to this sort of an approach. If we're putting our ductwork in conditioned space, and that could be through a number of methods, right? We could bump down a little soffit where the ductwork is all going to go. The HVAC equipment could be in some sort of a closet. We could be using mini splits, right? There's kind of a host of different ways to do this, but if the ductwork is in conditioned space, then that lets us go back to more of a traditional approach where we're putting now just loose fill on the attic floor, but then including a radiant barrier up under the roof deck, right? And again, this can be achieved by just specifying roof sheathing that has that foil, pre-laminated to the back side of it, or there are, kind of aftermarket products that can be used. Right. Previously, in the 2016 version of the code, there were more prescriptive options available, and based on how often other approaches were used, they kind of consolidated these prescriptive options down. The performance options is really everything else, right? If what a builder wants to do doesn't fall into those kind of buckets that we talked about, then kind of by definition, it has to use the performance path to show compliance. Oftentimes, this is unvented attics with spray foam, right? In this case, and we'll dig into the solutions in a little more detail here in a minute, but just the main thing to remember there is the code does have a mandatory minimum when we do performance approach for attics, and that's R22. So whether we're doing a spray foamed roof or any other kind of combination of materials, there's got to be at least R22 worth of insulation in this attic or cathedral ceiling system. From Johns Manville kind of perspective and a product solutions side of this, JM really has got we've got the broadest portfolio of insulation available in the market, and because of that, we have product lines that will hit all of the needs for high-performance attics in California. So we have our Climate Pro, which is our blown-in loose fill fiberglass. That's the photo on the right. We've got our formaldehyde-free fiberglass bats, the photo on the left. So, right, bats typically would go up under the roof deck. The loose fill would go down on the attic floor. And then, of course, we've got spray polyurethane foams, both open and closed cell, that can be used up under the roof deck to create what we would call an unvented attic. So we have options, a full range of product options for both prescriptive or performance path approaches. One quick note, though, about spray foam that maybe has come to your attention. California and actually Washington in the last year, well, just starting this year, have banned the use of hydrofluorocarbons, or HFCs, as in spray polyurethane foams. And where this really comes in to bear is on closed cell foams. Just to let you know, Johns Manville will be releasing what we're calling a Gen 4 closed cell spray foam that actually meets this requirement, and that'll be happening later this year in 2020. So from a perspective of what can I do if I want to use closed cell foam, there is still a JM option that will be available to you. Open cell foam, which honestly is the more common product that we see used in California, is not affected because the blowing agent for open cell foam is just water. So there's no HFCs involved, and so that product is not impacted by this change. Real quickly, related to attics is buried ductwork. And this is something, the image that we've got on here actually comes from the Title 24 Residential Compliance Manual, and historically, the image here on the left is really what needed to be done. And what buried ductwork allows you to do, if you take this sort of an approach, is it lets your ductwork be considered to be in conditioned space, even though it's still technically in the attic, right? So what we've got to do to achieve this is create a way that the ductwork is buried under at least 3.5 inches of insulation. That's then what's called a deeply buried duct. A deeply buried duct is effectively counted as being in conditioned space. And the reason I bring this up is because this is an option that a number of builders are beginning to use, again, to avoid the task of putting fiberglass bats up under the roof deck, right? That, as you can imagine, there can be some challenges from a sequencing and logistics perspective for that, and this is one of the ways to avoid that. This is one of these approaches, though, that if this is chosen, it's got to be verified in the field, right? So your HERS rater is going to have to come out and make sure that these channels were actually built, that there's actually the correct amount of insulation over the top of the ductwork. And what we'll do later on when we talk about examples is we'll show how this benefits in terms of showing compliance to the code. On the wall side, there's been a number of changes. One of the big ones isn't for mandatory measures. So just like in attics, there are mandatory minimum amounts of insulation that have to be put into walls in California. For 2x4 framed walls, the minimum amount is R13, and it's been that way now for a couple of code cycles. For 2x6 walls, the minimum has been increased to R20, or because California really deals with U factors when they talk about walls, it's a maximum U factor of 0.071. What that really means is that if we have a 2x6 framed wall and it's 16 inches on center, we've got to put at least R20, whether fiberglass or foam, into that wall to meet that U factor. Other changes that have been made, again, were then to the prescriptive tables, and that's that the U factor for most climate zones has been reduced, in this case that means improved, to 0.048. It used to be 0.051. We'll talk about what that means in a second. In terms of actual insulation products, climate zone 6 and 7 in California, and if you see over here on the right, we've got a map of the California climate zones. 6 and 7, there's even an inset, because they're just these little thin strips of land down in Southern California, right along the Los Angeles and San Diego coast. Those are pretty mild climates. That's why those requirements didn't change, but everywhere else they did. And then finally, also window U factors. So windows, the prescriptive value used to be 0.32. That has been improved as well to 0.3. So windows and insulation values for walls have gotten more stringent. So again, kind of what does this mean in terms of, what I'm actually building? So for a U value of 0.048 in terms of basic wall design, if you are framing with 2x4s, 16 inches on center, that would be the equivalent of putting R13 in the wall cavity and doing R10 of foam sheathing on the exterior. If you're framing with 2x6, that means putting, at least from Johns Manville's perspective, like an R21 bat, which is the sort of fiberglass product that we sell, plus then R5 of foam sheathing. From a product solution perspective, we talked about the cavity insulation, the column here in the middle, right? So R13 fiberglass or Corbon open cell, and 2x4s, R21 fiberglass or R20 of Corbon open cell in the cavity. From a foam sheathing perspective, Johns Manville has got our AP foil polyisocyanurate foam sheathing. So for that product line, to get R10, we have a 1 5/8 inch thick material that gives us exactly R10, and for the R5, it's 3/4 of an inch. If you're a builder that is looking to move to more advanced framing styles, like this bottom row on the table, the 2x6 at 24 inches on center, then that gives you a little more flexibility, right? An option there would be something like our Spider Plus product, which in a 2x6 can actually deliver R23, and that would allow the foam sheathing to get even skinnier, right? Only 5/8 of an inch to get an R3.5, and all of these combinations we see here will all deliver that prescriptive wall performance. Finally, another big change in Title 24 this year is related to insulation installation quality, or what's called QII in the Title 24 code. And this really relates to both how well the building has been air sealed and how well insulation has been installed. Just to give you a feel for this, without QII, which previously had been optional, the software that is used to kind of model the energy performance of a house will assume that all the installed R values are reduced by 30%. So as you can imagine, that can be a pretty big hit. And now this requirement is prescriptive. So whenever we are trying to show compliance for our building, if we don't check the box that says we are taking QII credit, all of these R values that are being plugged into the software when it does the calculations will all get reduced, and there's actually an additional air leakage that gets introduced into that as well. So you kind of take a hit on both of those. What we show here on the slide is this image of what we call grade 1, grade 2, grade 3 insulation quality. And then we're showing this in walls, but this install quality really shows up for everything. And what we need to qualify for QII is this image on the left. We need insulation that fills framing cavities, does not have compressions or voids, doesn't have gaps. And there's actually, let me jump here to the next, because there are, we could, again, this is one of those topics that we could spend a lot of time digging into the weeds on. Inside the documentation, the reference appendices that go with the code, there are QII criteria for literally everything, for all sorts of air barriers and air sealing, right? There's caulking, sealing that's required, and there's also criteria for all types of insulation, right? It's not just fiberglass bats. It's loose fill, it's spray foam, it's foam sheathing. All of any sort of insulation type you could think of that you would want to put into a house has got a section within this appendix where they lay out the criteria that have to be met. And certainly one question that I've already heard in talking to builders is, you know, holy smokes, does that mean that I've got to have every single house blower door tested, every single house inspected? And the reference appendices do include a sampling procedure. Now, initially, you might have to have a lot of things inspected, but as compliance is demonstrated, there's a sampling kind of scheme that's introduced. So you really need to want to consult with your HERS raters or your energy consultant for details around this. Again, we're not going to dig into the weeds on that one, but just to kind of maybe put everybody's mind at rest, it doesn't mean that every house forever after, for all of time, will have to be inspected and tested, right? So long as good performance is demonstrated, then it becomes not an every one, more of a sampling procedure. Okay, so we're going to dig into samples and solutions. The approach that I took here was to use, it's called CBEC Res. This is the software. It's a free software tool that California puts out, and it's basically the tool that's used to show compliance with the code. What's nice about this software is that it comes with examples. And so that's what we're going to work from, right? There are 1- and 2-story options. There are options with different sorts of heating and cooling equipment, with different sorts of battery and renewables. There's a lot of those. We're not going to dig into all of those. What I'm focusing on is, because we're looking at building envelope and insulation options, right, we're going to focus in on this, and we're going to use just kind of the 1- and 2-story options that are just provided with the software. So just to give you an example, so the table that we have here shows really the 3 baseline designs that we're going to be starting with today, and then we're going to start turning some knobs in terms of insulation, air sealing, some other things. So to kind of look at this table in a little bit of detail, first off, unless we mention it otherwise, the assumption is that all of these buildings are sitting in California's Climate Zone 12. That would be Sacramento in terms of a major city. We are going to look at some examples in some other climates in California, but we'll talk about those when we get there. And just to give you a little bit of detail, under attic, right? So when I talk about attic insulation levels, the R38, the first number, would be the loose fill insulation, in this case fiberglass, on the attic floor. The plus R19, right, the R19 would be a fiberglass bat up under the roof deck. The exception there would be, like in this bottom row where we say R40 SPF UVA, so that's shorthand for R40 spray polyurethane foam. UVA stands for unvented attic. So in this case, right, we've moved all the insulation to be under the roof deck. The attic is now sealed, right, and our HVAC system is in what's considered mostly conditioned space. The next column, the ductwork, when we say something like R8 in the attic, that really means that we're using R8 flexible ductwork, and it is literally exposed. It's considered to be exposed in the attic space. There might be insulation kind of heaped up around it, but it's not buried, and we'll get into that here soon. On the wall side, again, the first number, the value on the left, is going to be the insulation that's in the wall cavity. So in this case, right, if we're framing with 2x6, it's going to be R21. The R value that we're going to list on the right after the plus sign would be the foam sheathing that we're going to put on the outside of the building. So in this case, the R5 would equate to our 3/4 inch AP foil foam sheathing. And finally, the last column, that's the important one. That's the one that we want to start paying attention to as we walk through these examples and solutions. The term is called compliance margin, and what that really is telling us is how many EDR points are we better than the minimum code level that we need to be? So in all cases, we'd like this number to be positive. If it's negative, I'm going to highlight that, and we're going to talk about it, right? But what we're going to really talk about is, you know, different trade-offs we can make to still be in compliance with the code. And one of the first things I think everybody should notice is that just from these example kind of baseline prescriptive designs, they're already a little bit better than the code, right? So if we just designed our houses to kind of meet these examples, at least in Sacramento, right, we're going to be in good shape. We're going to be code compliant already. So next, buried ductwork, right? We talked about that a little bit. And so again, we're going to start off real quick, right? Those first two attic designs, and whether or not buried ducts works really depends on your climate zone. So if we were to do, let's say, some deeper attic insulation, R49, and if we did some measures to let us claim that that R8 ductwork is buried, and we're still in Sacramento, notice we lose a little bit of margin, but we're at 0. So we are still in compliance with that sort of an approach. However, if we take that exact same house and plunk it down in Palm Springs, where it is arguably hotter in the summertime, now we're not in compliance again. So what you're going to see as a recurring theme is a lot of these, how effective a given trade-off can be really depends on the house and where you're building, and it requires a conversation with your energy consultants. Another one that comes up a lot is, you know, a lot of builders are not used to using foam sheathing, though in reality it's not all that hard, but they might want to try to find ways to avoid using foam sheathing if they can. So again, starting off with our same two baseline homes, right, the 1 and 2 story. If we look at the 2 story and we just eliminate the R5 foam sheathing, we left everything else the same. We did lose a little bit of performance there, but notice we're still in compliance. So in Sacramento, we could successfully make that change, not use the foam sheathing, again, with this baseline house, and things are okay. We could, but if we were framing up with 2x4 walls and we only have R13 in the wall cavity, that's not going to be enough, right? So again, there's got to be some decisions there. Likewise, if we take that 2x6 framed house and drop it in climate zone 16, let's say Truckee, like outside of the Tahoe area, then we very much suffer, right? That definitely does not comply because, as you can imagine, in a colder climate, like the Truckee area, foam sheathing is really important for good wintertime energy efficiency. Finally, we can, again, we can do another trade-off, though, where we can do, let's say, more attic insulation, right? This last row shows us doing R49 in the attic, still with the R19 under the roof deck, and again, we can get rid of the foam sheathing. So there are a host of trade-offs that are possible. Another question that does come up is, what about if I want to do spray foam, right? What sort of benefits do I get, right? The main benefit that we tend to get from spray foam is an unvented attic, right? So this very first row is that baseline example again, where we've got R40 spray foam. The ducts are now considered to be in conditioned space, so our compliance margin is good. What if we want to put less than R40 spray foam in our attic, right? What if we bring it back to that mandatory minimum of R22? Well, now we don't quite get there, right? That now that red shows that we're not meeting the code. We've got to kind of at least do R30 or so, right, to show compliance. What if we try to take advantage of improved air sealing? Right, that's this last row that we just rolled in. So the basic air leakage or air tightness that's assumed in California is 5 air changes per hour. And so what if we were to say we're going to cut that in half because we're going to do an all spray foam house? That still doesn't quite get us there, right? It doesn't let us eliminate the foam sheathing necessarily. You know, frankly, what ends up having to happen is not only do we want to get credit for the air sealing, but we've got to do something else. Like in this last example, right, we've improved the efficiency of the air conditioning system, right? And now those combinations are something that could work. Finally, or as we touched on in that last example, the software lets us do a lot of trade-offs, right? We can do things like this first row, improving furnace efficiency in climate zone 16, which is again colder climate, right? Where we could maybe do more attic insulation with a raised heel truss, which actually lets that loose fill maintain its thickness out to the edges, and then still needing foam sheathing though, right? And we get a small positive compliance margin. Similarly, the second row, right, if we improve the air conditioning efficiency, right, again, we can show some good performance there. Jumping kind of down to this bottom one, right, improving the windows, right, can be another option to, let's say, eliminate the foam sheathing on the walls. There just are, almost an infinite number of ways to slice and dice this, and really what it becomes is, this should be the beginnings of a conversation between your energy consultant, potentially your HERS rater, and your insulation contractor, because certainly different things, different insulation approaches are going to be easier or harder depending on what gets chosen. So we're going to pivot real quickly to cover a couple of other things. One thing is multifamily. In the new Title 24, multifamily buildings have been separated, is separate and different from single family. HPA stands for high performance attics, and that really is similar, both high performance attics and walls. Actually, those requirements are very similar to the old 2016 version of the code. I think as we look forward, we're going to see those get tightened up as well, but for now, they look a lot like the 2016 version. Eventually, as we noted here at the bottom of the slide, multifamily and hotels will also probably get removed from the non-residential code, and it will all kind of get glommed together. That's at least the discussions that I've heard proposed at some stakeholder meetings that have already started. So to kind of summarize just real quick on this year's, the 2019 Title 24, and kind of what does this mean to our buildings and to our insulation contractors, I think we're going to see more R19 and R20 and R21, right? It's just going to be needed. We're going to see more foam sheathing. It's just going to become increasingly harder to avoid using those sorts of products. I think we could definitely end up seeing more spray foam, especially builders choosing to do unvented attics as a way to kind of quickly get your ductwork into conditioned space and get the kind of credits for that. And again, more HERS inspections because of the requirements for QII. At its heart, more builders are going to be forced to make changes because even the folks that previously were able to do trade-offs and use renewables against some of these efficiency measures, now that's no longer possible. Looking ahead, as I mentioned, the development of the 2022 Title 24 has already started. It actually started before the holidays, and proposals are being talked about in stakeholder meetings, and actually those meetings are open to the public. If you go to the California Energy Commission's website, there are links to these stakeholder meetings, and you can participate, and public participation is encouraged. The next round of the code is expected to focus more on non-residential, with looking at things like cool roofs, thermal bridges, things like that. On the residential side, a proposal that's been put forward is to show that houses that comply with passive house rules could have that as another compliance option. Washington State is another one looking ahead, looking a little beyond California. Washington has had a number of pretty dramatic improvements to their energy code, both the previous cycle and the one that's going to go into effect July of this year, where there's kind of some base requirements, and now there's a menu of options that must be chosen from to move even more energy efficiency measures into buildings. Of course, there's the Model Energy Code, the IECC. The new 2021 version was just voted on back over the holidays, and so over the course of this year, you're going to see that being rolled out. There's a lot of changes to insulation in that code as well. And of course, finally, there's things like stretch codes, which states like Massachusetts, New York State, Vermont, other jurisdictions have, and then, you know, beyond code programs, right? So all of these are things that are out there that tend to be beyond the code, but a lot of builders choose to just use them for marketing reasons or, you know, get implemented by cities and more local jurisdictions. Additional resources. Johns Manville has developed a couple of insulation guides. Now this year, because single and multifamily are different, we have 2 different guides out there, one for single and one for multifamily. Again, the focus is more on the prescriptive compliance options and solutions to get there, right? But these should really be good starting points to have these conversations with your insulation contractor, with your energy consultant about approaches that are available off the shelf with today's products that let you show compliance. And then, of course, beyond just, you know, manufacturers, you know, use your resources. Your insulation contractors are an excellent resource, right? They understand the practical logistics of implementing these solutions. Also, California specifically has got a number of resources. There's Energy Code ACE, which is an awesome online tool. There are a host of energy consultants in the state of California, and their whole job is helping you demonstrate compliance with the code. And then finally, your HERS raters, right? Those are going to be the men and women out there doing these QII inspections, doing these blower door tests for air tightness. They're going to be the ones at the kind of the sharp end of the stick, making sure that the solutions we put on paper get implemented in your buildings. Finally, JM Tech Connect is another resource available. You can see the phone number there. And this is really a group of professionals at Johns Manville, right, online, available through the website and on the phone, and also who can actually go out to your job site if needed. They can offer training and troubleshooting for insulation contractors, really with the goal to make sure that JM products are always going to be installed well and perform the way we want them to and you need them to. With that, I'm handing it back off to Kim for last bit of housekeeping and then questions.
We are going to get to some questions, but for everybody who attended today, you will receive a certificate of completion. So with that, we had a number of questions that we submitted, were pre-submitted prior to the webinar, so we'll address those first. And then after that, we will get to the questions that have been submitted during the webinar. So JR, our first question is, what are the differences between fiberglass and mineral wool?
So there are, my first inclination is to say there's not much, but I mean the main difference is what they're made out of. So fiberglass is glass fiber, mineral wool is more of a basalt product. It's like a volcanic rock that's been fiberized. From a thermal performance, mineral wool tends to perform a little bit better than fiberglass, and the big difference, the big driver for using mineral wool versus fiberglass tends to be fire performance. Mineral wool melts at a much higher temperature than fiberglass does, even though neither product burns at all. They're both non-combustible. You know, the big driver to choose one versus another is usually fire performance. Oftentimes, like in multifamily, for party walls, the 1 or 2 hour fire ratings we need kind of require mineral wool often.
Excellent, thank you. Speaking of fires, off-gassing as a result of the fire, are there any safety concerns that we deal with when the material is in a fire?
That's a good question. So in general, all of our products, all of our building products have to get tested for what we call flame spread and smoke developed ratings, and that's in kind of in a standardized test. And that certainly measures the amount of smoke given off, but beyond that, we don't really, like the code doesn't require, and we don't really dig into questions of, let's say, toxicity. I mean, I think the safe assumption is that if there's a building fire, all the smoke is bad and we shouldn't be breathing it. So, especially given all the things that are usually inside of our home. So, I guess we don't address that specifically as a manufacturer.
Excellent, thank you. Are there any safety improvements with the JM fiberglass going from the brown binder to the white acrylic binder?
No, there's no actual, that doesn't impact the safety of the product whatsoever. I would say fiberglass is equally safe, whether it's white or brown.
So can you talk a little bit about thermal breaks at vaulted ceilings between recessed lights and roof sheathing?
That's a good question. that's a little bit in the details. Certainly the code, to my knowledge, doesn't get to that level of specificity. So, I mean, my general guidance with that, to not spend too much time on one question, is, you know, we should try to make sure we maximize the R value above a can light, right between a can light and the roof sheathing, though of course we also have to be sure to maintain whatever clearance we need around there for fire code. Dig into that, right? It doesn't say, oh, you've got 20 can lights and now therefore there's a penalty to your roof system. So it's more of a best practice versus a compliance question.
All right. Can you also discuss a little bit about air barriers on conditioned attic walls and over exterior walls behind fireplaces?
So for conditioned attics, I mean, the air barrier for a conditioned attic is typically the roof deck. And then beyond the roof deck itself, we have to install blocking at eaves. And then if there are gables, we need to air seal those. Now, if the conditioned attic is being achieved with spray foam, the spray foam typically does that. We install the spray foam thick enough that it acts as an air barrier as well as the insulation. If we're using some other material, then we've got to get that air sealing done first, you know, with caulk or canned foam or other products. Related to, I'm sorry, fireplaces?
Exterior walls behind fireplaces.
So, and frankly, this is one of those challenging areas, and there might even be some guidance in this around the QII, in the QII documentation, but right, because we have to maintain clearances around fireplaces, that can sometimes become a challenge when it comes to air sealing. And typically the easiest way to air seal an exterior wall around the fireplace is to do it on the outside so it's away from the fireplace. And then at the top, if there's an open kind of chase visible, that's got to get capped off with usually something rigid like gypsum board. Then we can air seal up at the lid before it goes into the attic.
Excellent. So the next question is, what's the status of hemp materials in insulation, bricks, stucco, and other applications vis-a-vis building codes?
That's a great question, and I'm afraid I don't have an answer to that. Sorry.
JM does not have a hemp insulation.
We don't have a hemp business, so
Fair enough.
not familiar with that.
Is Title 24 addressing manufacturer equipment curbs and required R values?
So that sounds kind of like a commercial roofing style question, but I would say today I don't believe it does. However, I would expect in the 2022 version, where there is going to be more focus given to thermal bridging in commercial buildings, it may. Again, everything related to the next version of the code is still in the proposals stage, so I guess more to come on that one.
Okay. Are attic radiant barriers still part of the prescriptive code in Title 24?
They are still part of the prescriptive code. We touched on that a little bit. So if you're basically, radiant barriers are called for in most climate zones if there's no insulation up under the roof deck. Again, that's from a prescriptive standpoint. So let's say we put our ductwork and our HVAC down in the conditioned space, then we would do loose fill on the attic floor and a radiant barrier under the roof deck. And so that does show up in the prescriptive tables.
All right, thank you. The next question is, can you talk a little bit about vapor barrier placement or concerns in climates that have a large temperature range from, say, 40 degrees to 100 degrees Fahrenheit?
So, yes, we can talk about that a little bit. You know, honestly, in California, at least to my mind, as somebody who deals more with, with buildings all over the country, is pretty mild. Vapor retarders, I'm going to say, not vapor barriers. Vapor retarders tend to get really needed more in colder climates. So California, let's say Truckee, right, the mountains, somewhere where they actually have a cold winter. But then the rules for vapor retarder placement are the same as anywhere else. They should be more to the interior, what we would call the warm in winter side of the wall. I think when we talk about other parts of California that maybe see, let's say the Bay Area or something where we might see hot summers and cool to cold winters, then the rules get a little more flexible. And oftentimes we don't really want a vapor retarder, right? We would rather let moisture just flow through. The California Building Code, and there it's actually Title 24 Parts 1 and 2, do have some requirements around that, and those haven't changed. Those rules don't really move around much because they're based on physics, not energy savings.
It's always good to base rules on physics.
It's always helpful.
So what product would you recommend to meet the exterior 1-foot foam requirement for plaster and wood siding?
1-foot foam. So maybe they meant 1 inch?
Maybe. 1 inch.
So let's assume it's a 1 inch, because I don't know of anything requiring 1 foot of foam. If you need, so really it comes down to not, as we kind of talked about, it's not so much a thickness requirement, it's an R value requirement. So for John's Manville products, 1 inch of our AP foil foam actually gives us R6, which would be more than the prescriptive R5 we talked about. If it's a 2x6 wall, wouldn't quite get us there if somebody was only framing with 2x4s, and then it would call for R10. But again, this becomes part of the conversation maybe with your energy consultant, because you could, do maybe more attic insulation, and maybe that would let you reduce R10 over a 2x4 just down to R6, which would be 1 inch. Certainly one of the nice things about JM's AP foil polyiso foam sheathing is R6 per inch is a pretty high R value, right? That's more than most other foam products out there. So that lets you do thinner foam sheathing, which makes it easier to do things like flash your windows.
Excellent. So the next question is a little bit about Cal Green, and they talk about wanting sound-resistant walls. Can you comment a little bit about that in relation to insulation?
Sure. So sound-resistant walls, the easy answer is sound-resistant walls need insulation. Typically, for most kind of wall assemblies that we would want to get sound performance out of, the difference between having insulation and not having insulation can easily be an impact of 5 STC points, which STC stands for sound transmission class. That's the single number rating we use to rate the insulation performance of building assemblies, and that's usually the sort of value that shows up in the code. So I would say in general, insulation is always important. The other question that does sometimes come up is, well, what about fiberglass versus mineral wool? I will tell you that in the laboratory, we don't see a huge difference, right? Sometimes you might see a difference of 1 STC point between the identical wall insulated with fiberglass versus mineral wool, but usually that decision, again, is driven by fire performance, not sound. You just want something porous in that wall.
Excellent. So just for the audience, we are coming up right to the hour. We have about 10 questions left, so we will sit tight on the call and continue to answer these questions.
Sure.
And if you need to drop off but would like to hear the questions, they will be live in our recording here at the in about a week or so, and that'll be on our webinar on demand. So with that, we'll get to the next question, and that's for you, JR, which is, will the air tightness test require, or what do air tightness test requirements entail? Entry and exit testing required, and is there a minimum project size for the requirements?
So first, I guess, on the testing itself. So for homes, that is going to be what's called a blower door test. And I don't want to spend too much time on that, but that is something that your HERS rater does. It's basically a calibrated fan in a frame that goes inside an exterior wall to the building. We depressurize the building, and then we're able to measure then how much air is being moved through that fan to depressurize the building. That testing is done at a minimum at final, right? Because that's when it really counts. However, depending on the contract or service you get from your HERS rater, they might do it more often, because sometimes doing it earlier than final gives an opportunity to correct errors or leaks that got missed earlier in the steps. And so that becomes really a conversation with them. In terms of the requirements on size of the buildings, to my knowledge, new buildings are going to need some amount. Now, when we talk about things like additions or what they call accessory dwelling units, like basically putting a second little tiny home on your property, that's a good question, and I don't know the details of that, though I'm sure the code has some thresholds for that. If something is suitably tiny, there's probably not a requirement for it.
All right. Is picture frame air sealing now required within each bay at the exterior walls?
So from a prescriptive perspective, no. Right? When it comes to air sealing, the big thing is really, did we achieve the air sealing? So I'm going to say you don't have to picture frame air seal every single stud bay, unless that's how you're going to achieve your air sealing, right? But if you're really going to achieve your air sealing by, let's say, taping house wrap or taping and sealing your foam sheathing, right, then you probably don't need to picture frame your bays. And so again, this becomes a great topic to talk about with your insulation contractor, who's usually also your air sealing contractor, right, in terms of what's the most effective way and cost-effective way for them to get you to your goals.
All right, does the new ruling in Sacramento not requiring solar have any impact on Title 24?
That's interesting. I was not aware of a ruling like that, but I would imagine no. I mean, I know Title 24 is requiring solar on homes, and unless something happens, usually state trumps city. So I guess we'll have to wait and see on that one.
All right, that's going to be a pretty interesting topic, I think.
It will be.
Is there a minimum SHGC for windows?
So there is, and I didn't talk about that. Excuse me. And I do think actually that the SHGC, just for everybody's benefit, stands for solar heat gain coefficient, and it's a measure of how well your windows block heat from the sun from getting into your house. And in this case, a higher number is better. That means it's rejecting more heat. I do believe the SHGC requirement for windows increased. I could not tell you off the top what that number is, but it did also change this version of the code.
All right. Are these products available on the East Coast? I work on projects all along New Jersey, the New Jersey coast, and they've been using zip-R sheathing for an R5 through R19 bat. And I believe this was when we were talking a little bit about the AP foil foam.
So, wait, so which product? So I know Johns Manville's products are available.
Yes.
Certainly, right? So our AP foil products are available across the whole continental U.S. and Canada in probably any thickness. Up to 4.5 inches, I think, is what we make it. But so yes, the products that we talked about in the webinar today are available definitely beyond California.
All right. Do these regulations apply to accessory dwelling units like tiny houses in California?
So I believe they do. Again, there's probably some thresholds in terms of size, but I do think the idea is that these things apply to ADUs as well. All
right. Is there a compliance model with 2x4 walls, R13 bats in wall, and R5 exterior?
Yes. So I would say that would not, from a strictly prescriptive standpoint, no. But given that the vast majority of builders in California use the performance pass, right, I would say there are absolutely ways that you could have a 2x4 framed wall with R13 in the bats and R5 on the foam sheathing and still be compliant. However, right, that might mean that you've got to do maybe you need R49 in your attic. Maybe that means you need some slightly better than minimum windows. It may mean, right, you need a better, higher efficiency AC unit, right? Again, this is where we got into that question of all the hosts of other things you could do, and that becomes a great conversation with your energy consultant.
All right, and finally our last question, and that is level 1 for the bat install the only level that passes QII?
Yes, that's the short answer. So, right, so ResNet, which is more of that the national organization that's developed these grading, grade 1, grade 2, grade 3, gives a little more of a continuum, right? But essentially for QII credit in California, if it's not grade 1 quality of install, it might as well be grade 3. Like that, it's kind of just a pass-fail in California, not a continuum.
Awesome. Well, JR, thank you so much for your time today. And for everybody who stayed on, we hope you found this webinar helpful. We hope you guys have a great rest of the week.